Yo, welcome back. It's day 6. We're doing Advent of Code. Yesterday was a wild ride, so hopefully today's going to go a little bit smoother. If you're new to the series, my name's Ryan. Every day I've been doing Advent of Code problems. Each day has a part 1 and a part 2, so you get 2 stars if you finish it. It's pretty late in the evening, and I'm about to try out day 6. So I haven't seen this problem yet. What we're going to do is we're going to walk through solving the problem together using Elm. I'm going to be using Ellie, which is kind of like CodePen for Elm. So I'll be writing code on the left, and then if I hit compile, it'll show the result on the right. And we're going to be using Elm's pipeline operators to make sure that we can walk through it step by step, and hopefully you'll have a good understanding of how we got the answer that we got. So with all that being said, let's dive right in. I'm going to open up day 6 and we'll check out part 1. Okie dokie. Day 6, wait for it. The ferry quickly brings you across Island. After asking around, you discover that there is indeed normally a large pile of sand somewhere near here, but you don't see anything besides lots of water and the small island where the ferry has docked. Something about Desert Island. Sign up as a competitor in boat races. All right, as part of signing up, you get a sheet of paper, which is our puzzle input, that lists the time allowed for each race and also the best distance ever recorded in that race. To guarantee you win the grand prize, you need to make sure that you go farther in each race than the current record holder. The organizer brings you over to the area where the boat races are held. The boats are much smaller than you expected. They're actually toy boats, and each with a big button on top. Holding the button charges the boat, and releasing the button allows the boat to move. Boats move faster if their button was held longer, but time spent holding the button counts against the total race time. You can only hold the button at the start of the race, and boats don't move until the button is released. For example, if we had time 7:15:30, distance 9:40, 200. This document describes 3 races. The first race lasts 7 milliseconds. The record distance in this race is 9 millimeters. Second race is 15 milliseconds. The record distance in this race is 40 millimeters. And the third race is 30 with a record distance of 200 millimeters. Okay, your toy boat has a starting speed of 0 millimeters per millisecond. For each whole millisecond you spend at the beginning of the race holding down the button, the boat's speed increases by 1 millimeter per millisecond. So because the first race lasts 7 milliseconds, you only have a few options. Don't hold the button at all. That is, hold it for 0 milliseconds. The boat won't move at all, and it'll move 0 millimeters. You can hold it for 1 millisecond. Then the boat will travel at a speed of 1 millimeter per second for 6 seconds, reaching 6 millimeters. I can hold the button for 2, giving the boat a speed of 2, 10. Got it. So looks like 3 and 4 gets me 12 millimeters. 5 milliseconds causing the boat to travel a total of 10 millimeters. 7 also gives me 0. So I feel like that was symmetrical, right? It was, if I hold it for 1, 2, 3, 4, 5, 6, or 7, I end up with 0, 6, 10, 12, 12, 10, 6, 0. That was for an odd one. I feel like this is there's a thing in math that does this. Whatever, we'll get into the solution in a bit. Since the current record for the race is 9 millimeters, there are actually 4 different ways you could win. You could hold the button for 2, 3, 4, or 5 milliseconds at the start of the race. Okay. In the second race, you could hold the button for at least 4 milliseconds and at most 11 milliseconds to beat the record, a total of 8 different ways to win. The third race, you could hold the button for at least 11 milliseconds and no more than 19, you could still beat the record, a total of 9 ways you could win. To see how much margin of error you have, determine the number of ways you can beat the record in each race. For example, you multiply these values together, you get 4 times 8 times 9, which gives us 288. So determine the number of ways you can beat the record in each race. What do you get if you multiply the numbers together? Okay, so this is our input. Let's take this here. So how these puzzles work is we're going to have an input here on the left, and what we want to do is kind of parse out the information for these things. We can use some Elm to do that. But then our puzzle input is going to be like bigger numbers. So when it comes time to actually solve the problem, we're going to have these numbers instead. Um, I'm pretty sure there's like a pattern to. It's like a polynomial math thing. I don't know if it's going to come up. We can just do it the dumb way and see if that works. Um, but it's like two. This went up by two. This went up by six. I don't really remember how it works. Um, but yeah. So if we had seven, so it's one, two times whatever. So I feel like the ones in the middle are going to be the best. But I'm looking at the puzzle input, and I don't think these numbers are big enough for there to be an issue here. So we can just kind of work our way through all of the options and get the answer for part one. I think that'll be okay. So for part one, I think we can do it just with just simple logic. So let's figure out. Let's see if we can get some code that gives us these values: this one, this six, this 10, this 12, etc. So what I'm going to do is I'm going to start with this string. We're going to use Elm's string.trim function. And what that gets us is gets rid of the new lines in the beginning and the end. We can do string.lines to split this into two separate items. So we have the time part and the distance part. And then what I want to do is say to race info. And so the race info is going to take in a line. We're just going to take in our lines. I guess this will be a list. So we'll return that as is. And what we want to do is say we only ever expect there to be two lines. So we expect the first line to be, the time, and then the second one is like the distance. And if that works, that's perfect. So we can say cool time and distance. But if there's anything else, if the list has 0 members in it, if something is wrong with the input, we'll just throw that away. Say nothing. So here you'll see that we've got a tuple. What we can do with this to get rid of the time colon is we can do some transformations here to this string. So we can say string.drop left, and then I'm just going to say drop time colon from the front. So here you'll see that we've got rid of the time colon. We can do the exact same thing to get rid of the distance colon. And then we're going to use a similar strategy to before. What we're going to do is we are going to say string.words, and this will break up things into spaces. It'll get rid of the white space. We can do, that's just like string.lines, but that's going to work with spaces instead of new lines. So now we have time like this. We have our distance like this. Instead of using a tuple, but I'm just going to use a record so that we can see. On the left, we're going to be able to see what's our time and what's our distance. So distance is 9, 40, 200. That looks right. Finally, I'm going to do a filter map where we're going to just turn these into actual integers that we can work with. And so this here, this data type, the distances, the times, these are, this is the information that we wanted to parse from our puzzle. So that's good. What I think I want to do next is loop through kind of each of the indexes, like each of our races, and then keep track of the duration of the race as well as like the record. So I think I kind of want to take this data structure and organize it around. I want to organize it around races. Then we just loop through each race and try to get information for each race. So I'm going to do let. And then instead of putting this in a record, I'm just going to have distance and time be two variables. And then what I can do is time list.map. This is going to give us the number of like seconds passed. So this is just going to be a number. What we can do is we can say each individual thing here is going to be the duration of the race, just that number. And then what I'm going to try to do is pull the corresponding number. So I want to pair 7 and 9 together. I'm going to pair 40 and 30 together. I think there's a better function for this. Map to, which you can do tuple.pair. So really this would be the times, this would be the distances, and we would just rename these. And then I think I need to wrap this in a just to make it return a maybe. So here you're seeing that the 7 and the 9 are paired together, the 14 and the 50 are paired together, the 30 and the 200, etc. So what I'm going to do is say to race info is going to take in a list of strings, and it's going to turn me a list of these pairs, and I'm going to call these pairs just races. So this is going to give us all the information, and a race is going to have the time, which is an int, and it's going to have the duration, which is an int. And then rather than use tuple.pair to combine these things together, we're going to use race. So in Elm, you can use type alias names as constructors. So the first thing and the second thing will fill the first and the second slot. And then this is a list. This is to a maybe race here, right? Oh, maybe a list of races. So I'm going to say a list of races, and I'm just going to do it like this, where we just discard the information if the entire puzzle input is invalid. So I think with this, I'm just going to add some annotations to make it a little bit easier to follow what we have here. Here we had a list of ints, distances. We had a list of ints, and we use the map2 function to go through each of those lists together and then run the race constructor here to create a race and end up with a list of races at the end. So now this has all the information we need to like loop through and find like the optimal strategy for each race. So what I'm gonna do next is I'm just gonna see if we can get the numbers that we ended up with so we're gonna take that list, we're gonna map it, and then we're gonna say, let's go to, I don't know, like possible score. Duration is really like a record. So let's say 2 durations. And then 2 durations is gonna be a function that takes in a race and gives you a list of like the possible like values you could get for each race. So like if I held the thing down for 0 seconds, if I held it down for 1 second, all the way up to the max time that I'm allowed. So I'm going to say time and record. I'm going to destructure those. What I want to do is I want to say starting at 0, going all the way up to time. So like the time was 7. We're going to get a list of, I can hold it for 0 seconds, 1 second, 2, 3, 4, 5, 6, 7. So for each of these, we're going to convert this race into the possible number of seconds that I could hold the button down. So here you'll see that I could hold this down for 7. In this scenario, I could hold on the button for up to 15. And then in this scenario, I could hold the button down for 30. And so now that we have that, we can calculate like, okay, what is the number, like what would be the distance traveled for all these things. So if we held the time down for 0 seconds, let's do a list.map to duration, I guess. I'm just going to make a to duration function. This takes in the number of seconds that we held it down, and it's going to spit out how long it took us to or how far we traveled in the race. So time holding button. In order to figure out how far we've traveled, we're going to have to get our speed. And our speed is the time holding the button. So I'm just going to make a little variable here. This is unnecessary because they're always give the same value. What we want to do is we want to take the time we had minus the time holding the button. We're going to multiply that. Oops, I think I jumped up here on accident. We're going to multiply that by the speed that we're going. So hopefully for this 0 to 7, what we'll see is the answer that we saw here, where we end up with 0, and then we had 6, then we had 10, 12, 12, 10, 6, 0. So that's what I expect for the first item here when I hit compile. And so sure enough, that's what we get. And so now what we want to do is we want to take those durations, and what we should do is we should filter. I guess we could say, here what we could do is we could say filter each of these to, um, we only want to keep the things that beat the high score. So are more than record. So our more than record will take in our distance and it'll return true or false that it beat the record. So if we take in our duration, how long we took, and that's where we left off here when we ran to duration, we'll say if the duration is greater than the record time, we're going to keep it. So I think that's right. More than record, take a duration, it got stuck. Oh, I have a white space issue. So here, this is only keeping the numbers that are greater than 9. This is only keeping the numbers that are greater than, what was it, 40. And this one's only keeping the ones greater than 200. So that's actually perfect. This isn't very space efficient, but it is correct. So all we're going to do here is we're going to convert this. The puzzle was asking, once you know that information, take how many different things there are. So we can figure that out by using list.length. This will give us the 4, 4, 8, 9. And then at the very end, we can use list.product. I think this will give us the answer that we're looking for here. So 288 would be that answer. Cool. So 288 was the answer that they were looking for here. So it looks like our logic is right. Let's see if it works on our new puzzle. So for all these videos, I just put day 6, part 1. I'm going to save this here. And then what I'm going to do is I'm going to pin this here for later. And I'm just going to duplicate this. And by pinning it, I'm making it so that I'm going to share the link in the YouTube video below if you want to check out this code, run it yourself, mess around with it. But now I'm going to try it on my puzzle input and see if it works. So it looks like I got 840,336. Let's see if that's right. And that is right. Okay, cool. So that was part 1. Part 1 was kind of straightforward. No crazy challenges yet. We mostly just parsed some stuff. The weirdest part was using map 2. That might be new to you if you're new to Elm. So definitely, if you're interested, you should check out the package docs. I'll also have a link to these in the description. But you can check out examples. The core library in Elm is really nice. So if you want to better understand how map 2 works, please check that out. That's all available there. But what we're going to be doing is we're going to be trying out part 2. Part 2 is going to add a twist. Maybe our solution from before isn't going to actually scale, and we're going to need to do something a little bit more mathematical and smart. But let's take a look at part 2 and see, see what's new. Oops, I hit the wrong button. Part 2. As the race is about to start, you realize that the piece of paper with race times and record distances you got earlier actually has very bad kerning. There's really only one race. Ignore the spaces between the numbers on each line. Now instead, it means, instead of 7, 15, 30, it just means 71,530. So now we have to take that same logic and figure out how many ways are there to win if you hold the button down for anywhere from 0 to 71,000 steps. In this case, it looks like there are 71,503 ways to do it, which is kind of nuts. So what we can do is we're not going to be able to use that same strategy we had before, because that's going to result in a list that's like 80,000 members in it. I don't think that's going to work. But what we can do is piece by piece. Let's start by renaming this to part 2. And then piece by piece, let's kind of walk through how we can solve this. to just deal with one really, really big race where the possibility space is kind of massive. So I'm not scared of this. So this is where we left off, 288. What it's saying is that it's set with these numbers, our understanding of the race info was wrong. So rather than it being a list of races, what it really is we drop the beginning. We're going to trim the white space. So we're really going to replace this white space with empty space. And then what we're going to do is we're going to keep all these words. So we're going to have, we're going to have this be our record time to beat, and this be our time. So we just kind of modified this code. What this did was get rid of all the spaces by replacing all the spaces with like an empty string. And then we kept doing our words thing from before. So no big changes there. I think another way to do this is not to do it in a list, but we don't need to worry about that. Okay, so we have our race info. What we want to do is, like if I hit compile on like this part, two durations. What does two durations do? Takes a range 0 to time, map, filters. Yeah, so it did get the answer, 71,503. So it looks like for this record set, this gave us the answer we were looking for, right? 71503. So, I mean, I could save this and try it, but I think what we're going to find is that this is not going to scale for the big puzzle input we have. So maybe this is right. Maybe this is the end of the video, but I'm pretty sure we're going to run into issues when I paste this number in here where our computer or browser like times out. So let's just hit compile. It's going to sit, it's going to spin, and that's because we have 1, 2, 3, 4, 5, 6. We've got 62 million numbers that we're trying to add to an array in the browser. So that's not smart. We shouldn't be doing it that way. So I'm going to exit these pages. What we're going to do instead is I'm going to just refresh these. Is instead of doing it like this, we're going to need to come up with a different strategy to come up with that same number. So ultimately, it works fine for 71,000 numbers. But what we want to do is change the way we're going about this problem. So let's go back to the example that we saw here. You remember the symmetry with this problem where it was like you could go 0, you could go 1, you could go what is this? 0, 1. Sorry, you can go 0, 1, 2, 3, 4, all the way up to 7. But we saw there was a peak at 12 millimeters, and then it symmetrically dropped off. So like there was 12s, there was 10s. Let's quickly go back to that. So here, I think the easiest way to go back to that is to get rid of this product thing. We'll get rid of this type annotation. You remember how when we converted these, we ended up with, I'm just going to grab the first one, with this nice symmetrical 0, 6, 10, 12, 12. What I think we should do is we should take that number, that total length, we should cut it in half. And if it's even, then all we need to do is start at the middle and then just keep going to the left and calculating that number one at a time and just keeping track of how many numbers, like if we're greater than that threshold, that 940, 200 threshold, we just keep incrementing. And then whatever our index is as we go left to right, we just double it at the end. So the way that it would apply for this problem is instead of saying, okay, let's like take all these numbers, let's make a giant list with all the calculations, what we can do is we can figure out what's the midpoint. And then we can start one less than the midpoint. If it's even, we can start at the midpoint if it's odd. And then just kind of work our way one step at a time. And then as long as it passes the test, we'll just add one and go on to the next. So we're going to make a recursive function to solve that. So here, what I want to do is take list.map, and we're going to have a different two durations function. This is going to be our two durations part 2. So we're going to make a new function, and we're just going to start with a time and a record. And piece by piece, we're going to spit out information that we have. So here we have the time. That's what's getting printed out over here. And instead of list.product, I'm going to do list.head. It'll get rid of the this just, and I'm just going to do it maybe with default 0 here. Oops. We should never hit this 0 case. I'm gonna do a -1 just to make sure we never hit it. But this is just to get rid of the just in the beginning. So let's focus on part 2. So we have our time. We can do a bit of logic here. So we can say our time is even if we take our time, we mod it by 2, and that equals 0. So is 71,530 even? Oops, I gotta put this in parentheses. Oh, I'll just do this. Default, -1, screw this. We're gonna leave out the maybe with default for now. So that is true. So we do have an even number. So what that means is we're gonna find one left of the midpoint. So middle index is going to be the middle time that we're going to start with is going to be our time divided by 2. And when you divide an even number by 2, it's going to be, I think, 1. If it's less than 10, is that going to be one higher or one lower? Let's take a look. So we're going to have our middle index. That's at 35,765. So if we start there, we said we held it down for that long. I think we want to increment and then double that. So we're going to start with our middle index, and we're going to run it into this equation, this two duration equation. I'm going to pull this out. Just going to put it here for now. These are identical. We're going to delete two durations when we're done here. Let me just compile to make sure this is good. Okay. So how long we hold the button in the middle. So this is going to be a big number. So what we want to do is we want to test specific values and return true if they pass the test, or false if they don't pass the test. So are more than record will just be one single function. So the time holding the button, yes or no, is it greater than the record? So is middle index, the number at the middle, bigger than the record? Yes. If so, we're going to go in deeper. So we're going to keep looping until we find something that isn't greater than the record. So what I'm going to do is I'm going to just delete this for now, and we're just going to do this. We're going to do this on just 7 and 9 because those are numbers we understand. So the middle index is saying we're going to hold it down for 3 seconds. So 1, 2, 3. Yeah, it looks like that's giving us this here. So rounding down, and we're going to keep decrementing until we get the same answer, which is that we're correct. So if are more than record, middle index, then what we're going to do is we're going to keep going. So I'm just going to keep going. We're going to have 1 as how many we found so far. We're going to have our is even I'm going to pass in. I'm just passing in a bunch of information, like what we have. The next number that we're going to work with is going to be the middle index -1. Count. This is going to be is even. I'm going to use a record to keep track of this. And then we're going to say our number. It's going to be middle index minus this. And what I want to do is have this just be a function out here where I can just say race time and race record and not have to have this be nested inside 2 durations plus 1. So I'm gonna just comment this out because we don't need this one anymore. Format this. Oops, looks like I have something invalid. Oh yeah, my else. So if we're not more than the record, at this part we're gonna say 0 because there's nothing here. But this logic is what we're gonna be using inside of this keep going function. So we're gonna do this, format. So keep going, like we said, is gonna take in how many we found so far, how many things beat the record so far, are we even, true or false, and then what number are we at now? And it's going to return a number. So keep going. Count is even number. And we're just going to say if that number is more than the record, we're just going to take whatever our count is and add 1 to it. We're going to continue to propagate whether it's even or not. And then rather than returning 0 at the end, what we're going to do is we are going to say if this is even. So if we did have a symmetry where there's exactly the same amount on both sides, then we're going to return count times 2. That'll be our final answer. Otherwise, it's odd, which means we want count times 2 minus 1. So in the scenario where we had 7, the important thing is if we had 6, there would only be one number in the middle that would work. So we don't want to accidentally count the middle twice. That'd probably be easier to visualize if I kept this thing around. Let me just show you what I mean really quick before I get too far into this. So here, let me just comment this out. Sorry for the messy code. Stop map to duration. I'm just going to put this in here also, just temporarily. This is going to be upset. Index. Can I find a middle index variable? Oops, sorry. This is the number minus 1. Sorry, I didn't finish typing there. So that's going to use the number minus 1. If r more than record, we're going to give it the full race. Yeah, we'll just pass in race as an argument here. Sorry, I needed to add more context for this thing to compile. The race is going to be unchanged here. This is just information about the race. So when we had 7, remember we had 0, 6, 10, 12, 12, 10, 6, 0. The important thing to notice is that if this, if it's odd, we want to do the minus 1. And then if it's even, we want to do the minus 1. Because notice here, if we start at 9, if we take that 6 divided by 2, that's going to be 0, 1, 2, 3. We want to start counting out this way. And then if we find 6, we want to double it. If we find 3 things, we want to double that. That'll give us a total of 6. But notice that we only care about the 5 in the middle. So this minus 1 is going to prevent us from getting a bug. That explanation was kind of shaky. Maybe I should do these when I'm less tired, huh? You can tell it's probably the end of the Avena code run for me because my videos are getting a little bit, I don't know, I feel like they're getting a little bit confusing. Maybe I'm sprinting to the end a little bit too fast here. So keep going needs to know the race information. So the race is going to be this thing here. Race. Time. So we're just going to pass that in. Record, and we're going to pass in that race, otherwise we can't do the calculation. So just 0. More than record. Time holding the button. Oops, sorry, I left this at 6. I'm so confused. So we want this thing to say just 4. Okay, cool. the logic works. So we could test this with our big numbers that we had from before. So let me take the actual puzzle input from earlier, and hopefully this is another way to spit out that 71503 number. Great. So we did this the exact same way. Sorry, we got the exact same answer, but we used a different strategy for how to get there. So instead of the easy way, which was just look at all the numbers, calculate the durations, and keep the ones that are higher, what we had to do was do some logic and kind of start at the middle and work our way out. So hopefully, if we take puzzle input, let me delete all this stuff here. We're going to get the correct answer for part 2, and we can call it a night, and I can share all this code here. I'm going to just leave this as 2 durations part 2. Pilot, save this, and hopefully the performance of this will be good enough that we'll be able to actually solve the problem. So what I'm going to do is I'm going to take all of this, and I want to make it so we're using these numbers instead. So I'm going to hit compile, and look, it finished. So it's saying that we have 41 million numbers, at least for my puzzle input. It's saying 41 million. There are 41 million ways to beat the record. So if I hit submit, we did it. 1 gold star. So we've got a total of 12 stars here, and we're doing good. Let me switch back over here. Thanks so much for hanging out. Hopefully that wasn't an overwhelming explanation. I will be sure to share the code, and then you'll be able to read through it. I'm looking forward to day 7. I want to make sure I get through a week of this, so there will definitely be a video tomorrow, unless it completely destroys me and I'm too embarrassed to post it, which is not going to happen. Let's face it. I'm pretty good at this stuff. So yeah. So tomorrow I'll record the day 7 video, and yeah, I'll see you guys then. Goodbye.